Today, let's do some homework. Specifically, I want to take a look at the rabbit problem. We had a nice sinusoidal function with all the features, where y is the number of rabbits in thousands, otherwise known as kilo rabbits, at t years after 2015. So t equals 0 corresponds to 2015, t equals 1 corresponds to 2016, and so on. So that's what this means, t years after 2015. This is us establishing what 0 means. And this is telling us the thousands of rabbits. So I don't know if we actually call that kilo rabbits, but kilo rabbits, thousands of rabbits. We know that there are 4 things that we want to identify. That there are 4 things that we can identify about our sinusoidal functions. So if we have a sinusoidal function, y equals, we have a coefficient of the trig function. We have a coefficient of the x. We have a term outside of the trig function. And we have a term inside with the x. We know what each of these 4 constants represent in terms of the function. A represents the amplitude. So A, the absolute value of this number is the amplitude. B is in control of the period. It's not the period, but it tells us how to calculate it. The period is 2 pi divided by B. D is where the middle is. And C is our horizontal shift, which is where we can think of the start. So let's take a look at our function. Y equals 450 minus 25 sine of 2 pi over 5t minus 12 pi over 5. Right away, we have an issue. First of all, the 450 is the constant d, and that's been written first. So things are a little bit out of order, but we need to look at that 450 and say that is a plus d. A is the negative 25. That's in front of the sign. The negative 25 is getting multiplied by sine. So first of all, we have to recognize that. The other thing that's kind of messed up about this particular function is that we have bx minus c. This has all been multiplied out. I don't have b 2 pi over 5 times parentheses. So the 450 is where our middle is going to be. This is our average rabbit population in kilo rabbits. A is a negative 25. That's going to be our amplitude. Then we have the sine. Two pi over 5 is the coefficient of x, or in this case, t. But we're going to have to do some division to figure out what the horizontal shift is. Notice that the way we're given this function, it's 2 pi over 5t minus 12 pi over 5. The coefficient of t has been multiplied. So that's 12 pi over 5. That is b times c. So I want to rewrite this expression, 2 pi over 5 minus 12 pi over 5. I want to factor out the 2 pi over 5 and see what this constant is. We've taken the over 5 out, and we've taken the pi out. So if we take a 2 out of the 12, that leaves a 6. factor the 2 pi over 5 out so that I can have b parentheses t minus c close parentheses. So notice that the form here, b parentheses x minus c. The x minus c needs to be in parentheses so we can properly identify our horizontal shift. So we had to do a little bit of factoring to find out the horizontal shift. Any questions? A lot of times we don't like this. We don't like factoring 2 pi over 5 out of anything fraction, and we have been trained to just factor our coefficients or our integers. So it's really uncomfortable to factor that out. So let's think about it a different way. Let's think about this a different way. This is the form we need to read stuff. B times x minus c. We can identify b and we can identify c. B parentheses the x minus c. The problem is the one that we're looking at, this has been multiplied out. We're actually looking at bx minus bc. So without parentheses between the b and the x, we're actually looking at bx minus bc. So when we look at 2 pi over 5t minus 12 pi over 5, this 12 pi over 5 is bc. So b is 2 pi over 5. But the 12 pi over 5 is a combination. bc is 12 pi over 5. Because of the no parentheses thing. Look at the form of that we want, that we're able to read. B parentheses x minus c close parentheses. Look at the form we're given, just bx minus something. So without the parentheses, that means that constant inside the sign is a combination of b and c. So it's too much information. But I can replace b with a 2 pi over 5. So 2 pi over 5 times c is equal to 12 pi over 5. And we can solve for c by taking 12 pi over 5 and dividing by 2 pi over 5. I need to stop switching colors. So c is 12 pi over 5 times 5 over 2 pi. The 5's cancel, the pi's cancel, 12 divided by 2 is 6. I don't know which way is going to make most sense when you think about it. So you've got to think about it both ways and decide which one you like better. The thing that you can't get away from is the difference in our statement. 2 pi t minus 12 pi over 5 is not written in the form that we can read b parentheses x minus c. You have to see the difference there. You can either think about factoring out b or just take c and divide it by b. It's the same thing. That's how we got the 6. I took the 12 pi over 5 and divided it by 2 pi over 5. It just didn't look quite like I divided 12 pi over 5 by 2 pi. Okay. Let's read what these numbers are telling us. I suppose I should go look at the problem. I don't care what the questions are. Let's read what these numbers are telling us. So this 450 is the constant that we're adding after all this nonsense takes place. So this is D. D is equal to 450, and that's the middle. A is the negative 25. And so the amplitude is 25. We don't want to listen amplitude as being negative. Amplitude is a distance, and distance should be positive. The coefficient 2 pi over 5 will tell us about the period. The period is not 2 pi over 5. That's just going to tell us where the period, what the period is. So the period is 2 pi over 2 pi over 5. So that's 2 pi over 1 times 5 over 2 pi. So just 5. Now, if you're looking at this and saying this horizontal shift is ridiculous because it is greater than the period, you are correct. Your horizontal shift should never be greater than your period. That's ridiculous. But you should just move it over. And instead of having a horizontal shift -6, the period is 5. Move your horizontal shift to 1, -1. Instead of -6, write -1 to subtract off a whole period. Because that's like measuring an angle, and instead of saying the angle is 30 degrees, saying the angle is 390 degrees. That's just excessive. Unless you're doing Tony Hawk trim, then you want all those extra seconds. So let's read some more. We have this ridiculous horizontal shift of 6. So, but that tells us that we're going to start at 6. And because we have a minus sign, that means the mid going down is going to be at 6. Now we've got all of our details. So remember, we have all of these different starting points. Plus or minus cosine, plus or minus sine. Whether we're starting at the top or bottom for cosine, the mid going up or the mid going down for sine. Because my amplitude is a negative, and we're using sine, that means what the starting point will be the middle going down. Yes. Yes. So at 6, we're going to have a middle going down. So here's where we're going to start, and this is going to be a point that's at the middle going down. So that means 5 units later, that's 1 cycle, will be at the middle going down. 5 units before, that's 1 cycle, that'll be the mid going down. Because here is 1 cycle. If I want this to be the middle, we know the middle is going to be at 450. I think I'm most annoyed the period being 5, because I cut it in half and it's 2.5, and then I put that in half again for 1.25. You couldn't make the period 10. The half would be 5. Jerks. No matter, no matter. I know that halfway between 1 and 6. Well, actually, let's do top and bottom. We know that the distance from the middle to the top is 25. So from 450, that means the top is going to be at 475. So we do plus 25. The top is going to be 475. And the bottom will be at 425. Because the amplitude is the distance from the middle to the top and the middle to the bottom. We know that halfway between at the halfway between will be at the middle going up, and then halfway between each of those points will be at the tops and the bottom. So halfway between these points will be at the top. Halfway between here will be at the bottom. Halfway between we're at the top. Halfway at the bottom. So we can figure out when these things happen. Halfway between 1 and 6. 6 and 1 is 7 divided by 2 is 3.5. 6 plus 3.5 again is 2.5. 6 and 2.5 is 8.5. Or 6 and 11 is 17 divided by 2 is 8.5. But we've got a lot of information here. And here's our rabbit population increasing and decreasing and increasing and decreasing, fluctuating up and down. Notice that the period is 5. So from 6 to 11, that's 1 period. And I want to figure out where the halfway point is. I just average those, or I could take the period of 5, divide it in half, divide it by 2 to get a 2.5. 6 plus a 2.5 is 8.5. 8.5 plus 2.5 is 11. If we want to figure out where the top and bottom points are, these are going to be 1 and 1/4 in between . So if the 1 period is 5, 1/4 of the period is 1.25. So we start off at 1 plus 1.25 is 2.25. Plus 1.25 is 3.5. 3.5 plus 1.25 is 4.75. 4.75 plus 1.25 is 5.100, so 6. 6 plus 1.25 is a 7.25. Plus 1.25 is 8.5. Plus 1.25 is the 9.75. Plus 1.25 again is 11. Notice that between any two corresponding points, we have a period of 5. So At the bottom, the first bottom point we have here is at 2.25. The next one is at 7.25, 5 units later. At the top, 4.75 and 9.75 are 5 units apart. These two middles at 3.5 and 8.5, they're 5 units apart. And now we're watching this rabbit population in 2016 at 1 decrease, and then increase, and then decrease, and then increase, and then decrease. So this here 1 corresponds to 2016. 6 years after 2016 is, 6 years after 2015 is 25 and 6, 21. Plus 5 more, 11 years after 2015 is 26. 7. 5 years after. I keep saying the 6. 1 and 5. Is it 6? 6. 15 plus 11. $16 and 5 is 21. 21 and 5 is 26. Because our period is 5. Right? Yeah, this is 11 years after 15. It's not 6 years later, it's 6 years after 2015, because 0 is 2015. So over here, we'd have like a, so there's the 0 is the 2015. Oh, what were the questions even? How much did the rabbit population fluctuate? So that means what's the difference between the top and the bottom? That's not just one amplitude. It's how much does it fluctuate. The difference between the maximum rabbit population and the minimum rabbit population. So since our amplitude is 25, we should have two of those for 50 kilorabbits. What was the first year after the start of 2015 where the rabbit population was at its maximum? Round your answer down to the nearest year. So looking at our graph, we want to find when the rabbit population is a maximum. So we're going to go to 4.75 is when we hit the top the first time after 2015. So 4.75 plus 2015 is 2019.75, which means it's still 2019. We haven't got to the next one yet. That's why they said round down. Because what's 3/4 of a year? September? September 2019 is still 2019. We don't round that up to 2020. And say, oh, it's 2020. We're past July, so we got to round up. Oh, that was it. So many more questions that we could ask, but that's okay. So there were also, let's see. So 4.3 was about secants, cosecants, tangents, and cotangents. I don't want to look at those yet. There was another question on sines and cosines. Is it this one? So here's a similar problem. Here's a similar problem. House values have experienced tremendous highs and lows over the past several years. Average housing prices in houses, average housing prices in thousands of dollars for a specific subdivision are modeled by the function 200 minus 45 times the sine of pi over 4 times t. The main reason I want to look at this is that we live in California, and it says the maximum home price over the last several years in the subdivision is $245,000. $245,000. And at one point, average home housing price was 200 minus 45. What's that? 160 negative 5, 155, $155,000. I think my brother-in-law bought his house for $155,000. It's a 3-bedroom, 2-bath house with a large yard. Arizona. I don't know, it's kind of a long time ago. A little bit, yeah. I think my grandparents bought their house in like 1973 for like $1.50. That's what it was. Plus a couple of baseball trading cards or some shit. My mother-in-law had bought their house. It was in San Francisco. It was like 10 grand when they bought it. They did not know how they were going to pay that off. It was $10,000 for a house in San Francisco. San Francisco has like 1,000 different neighborhoods, so who the hell knows? No. It's close to Daly City. But seriously, San Francisco, get your neighborhoods under control. It's 49 square feet. You can't have 300 different neighborhoods. So notice that the structure of this problem is the same. We didn't have the extra complication of the bx plus c, or b times x minus c. We've just got a coefficient and the starting point is at 0. So there's no horizontal shift we have to worry about for this one. So the analysis goes the same way. And they actually ask the same questions. How much do home prices fluctuate over time? That's just going to be 2 amplitudes at 45 and 45 or 90. And the first year after 20, it even starts in 2015. I mean, this is my level of creativity. This is bad. But anyway, I shouldn't make fun. I'm not creative either. Was the first year after 2015 in which home prices reach a maximum? So notice the same questions. You still just have to identify the middle, identify the top, identify the bottom. We did a lot of extra stuff because we're extra like that. Oh, that's right. This one's still rabbits. Apparently, rabbits and home prices. That's the important stuff. All right. Let's take a break and then we'll come back and think about some other function.